Let's take a look at cellular automaton. A cellular automaton is a grid of cells with each cell in a certain state. We'll explain that in a moment. And with a set of rules that goes with the grid. Here are some examples of possible grids. A linear grid, or one-dimensional grid, is just a row of cells. A two-dimensional grid is a checkerboard or a chessboard. And we can also have three-dimensional grids as well. Let's take, for example, a linear cellular automaton. A cellular automaton which has just one row of cells as its grid. Now, when we want to start off, we need to color these cells or give each cell a certain state. The state can be a color, so we could give the first cell the color blue, the second the color blue as well maybe, and the third the color purple, the fourth green, etc. But the set of states don't have to be colors, they can also be numbers, so we can give each cell a different number. One could be the number 0, other could be the number 1 or number 2, if we choose these to be our states from which we choose. But we're going to have a look at this cellular automaton, or build a cellular automaton, which has as its set of states just two colors, black and white. So when we want to start off our cellular automaton, what we first need to do is to set it up, initialize the grid, give each cell in the grid a color, black or white. We usually use the color black and call it live, and when we use the color white we call it dead. But anyway, we'll use black and white for a moment. So let's start coloring. Let's give some cells the color blacks, the other cells white. And here we go. Let's put another black in here. And let's finish up with all these whites. Okay, so now we've given our cellular automaton an initial state. Each cell has been colored either black or white. No cell has been left uncolored. And this is also called the generation 0, or 0th generation of the cellular automaton. Okay, so we now have one row of our cellular automaton, and we also said with our grid and with our initial state we also need a set of rules. The set of rules helps us generate some more rows in our cellular automaton, and we use this set of rules to generate a new row. And we do this by giving each group of 3 cells from left to right. We go over these cells and then use them to determine the color of the center cell in the new row. So there are 8 possible combinations of 3 cells in the top, or in the row of the 0th generation. And for each of these we have a rule, and the rule tells us what the cell in the middle of the 3 cells underneath it is going to be colored. So now what we're going to do is we're going to go over our 0th generation row, triplet by triplet, in groups of 3, take a look, and then determine what the row underneath is going to look like. So if we start from the left to right, we have black, white, white. So we go to the rules, and we can see the black, white, white is the first rule, and that means that the row in the row next to it, the row under it, the next row, the center will be colored black. And then we'll go to the next 3 cells, go to this, and we'll see that these actually fit the second rule, and that means that the center cell in the row, in the new row, is going to be white, and we'll carry on looking at all these 3 groups of 3 until we finish. Let's take a look at this example in more detail. So here again are the same set of rules and the 0th generation row. And now we look at the first 3 cells in the 0th generation, black, white, white, and according to the rule we can see that the middle cell in the new generation is going to be colored black. So let's do that. We'll color the first generation, the center cell of the 3 cells underneath it. We're going to color that black. And now let's look at the next. Okay, here we have 3 whites, right? So this is the rule we're going to have to use. And 3 whites because in the zeroth generation, create a white cell in the first generation. And let's have a look. One will look at the next. So we have white, white, black, and this is the rule for white, white, black. It'll give us a black cell in the center cell below. So this is exactly what to do. We see that white, white, black generates a black cell in the one below, and we can use all the rules, and then we get a new row. You can see it's colored differently. It has a different pattern than the zeroth generation. You'll notice that we left the two end cells uncolored. And I said before, we don't leave any cells uncolored, so we have to decide what to do with them. Well, usually what mathematicians do is what's called a wraparound. That means we look at the whole row as if it's like a bracelet or a donut. It's connected back to front. But we won't bother doing this time. We'll just decide to color them white. We can do that as well. And that's really it. We've got now the first generation. Now we can apply the rules to the first generation and get the second generation, and then the third, and so on and so on. So we usually actually join the rows together because that way it makes a nice pattern. So all we're doing here really is just putting the rows one above the other, zeroth generation above the first generation, like that. See, it makes a nice pattern. And now we'll make a new row, again by using the rules. So now we look at the first generation, we see we have white, black, white. And if you remember before, white, black, white gives us white. And we can quickly use all the rules and generate the next row and the next row, and that's it. That's a nice pattern we've got. Now let's take a look and see if you can do that. We're going to give you an initial state and the rules that you saw before, and the zeroth generation, which is really the initial state. And you're going to apply the rules and see what patterns you can make when you apply them row after row. So let's go and do that.